Welcome everyone here to Managing Changing Data with FME. Our first part in this two-part series. Today we'll be covering compare and detect. I am joined by our three presenters today on the SAFE team. I'll pass things over to Donald to introduce himself first.
Yeah, hey everybody, I'm Donald. I've been with SAFE Software about 1 year and 3 months now at this stage, and I'm on the technical support specialist team with FME Form.
Hi everyone, my name is Emma Lei. I've been with SAFE for about 8 months now, and I'm also a technical support specialist on the FME Form team.
Hi, my name is Dave. I'm also a technical support specialist at SAFE Software and been working here just about 1 year now.
Awesome. And we also have Nampreet, Carl, and Mac joining us as well on the Q&A on the back end here today. So we have a full range of SAFers here and ready and eager to help you with any questions you might have during the webinar. With that in mind, I'll just note the questions tab is on the bottom right. So if you have any questions as we go along, please do drop those in. We'll have dedicated time at the end to answer some live as well. Keep letting us know where you're tuning in from in the chat on the bottom right. Share your emoji reactions with us on the bottom middle of the live storm room here. We love to see those as we go. And if you have any audio or video issues during the webinar, just click that help button on the bottom left for 4 simple steps to take. Our Peak of Data and AI is coming this May 6th to 8th to Seattle, Washington. We hope to see you there. Check out our agenda. It did get released a couple of weeks ago. And with that, I will prompt our presenters just to turn off their webcams so we can save on some bandwidth for the remainder of the webinar here as we go along. And I'll pass things over to Donald for our agenda.
Yeah, so I'm going to quickly run through the agenda just to give you a heads up of what's going to happen today. So I'll kick us off with an introduction to FME and a really cool transformer called the ChangeDetector. I will then run through a demo or a flash demo just to quickly get you used to the ChangeDetector transformer and just a quick introduction. I'll then pass it off to Emma, who will go through how to identify and apply attribute changes, as well as how to identify and apply geometric changes. Emma will then pass it back to me, and I'll go through data synchronization. And then Dave is going to wrap it up with one final demo on how to report changes. I'll quickly run through a conclusion before handing it back to Elizabeth, who will go through resources and next steps before wrapping it up with a Q&A. Yeah, so I'm going to kick us off with a quick introduction. So Heraclitus, near 2,500 years ago, said, "The only constant is change." This is still as relevant today as ever, and I think it will be pretty hard to find anybody who disagrees with that statement. There is change everywhere throughout the world. There is no exception. But what does that mean for us? Our data is constantly changing, and it's up to us to be aware of these changes and how to combat and utilize these changes. Changing data can be scary. It can be hard to keep track of what is happening when everything is constantly changing and there's moving parts everywhere. With FME, these fears can be washed away. No matter what type of data you have or what stage it is in your workflow, working with changing data can be easy. You no longer have to fear it, but rather you can embrace it. So why do we care about changing data? Simply put, it's important. It's great knowing that your data is there, but it's extremely important to understand why and how your data has changed from what it was yesterday. Changing data often impacts the actions that need to be taken. It can affect quality reasons, productivity reasons, and efficiency reasons. Detecting this changing data helps streamline what is happening and saves a huge amount of time and removes any tedious work that needs to be done, something I'm sure we can all get on board with. There are a bunch of different methods for managing changing data. Here are 4 common methods. The first one, diff, which we will primarily focus on today. So this is for comparing the current state of the data with previous states of the data. So this is to identify what has changed. We have modification timestamps, which is a filter is run against a date field to retrieve rows that were modified since the most recent time or data was extracted and added. We have database triggers or webhooks. These are triggers that can be used to perform CDC in shadow tables. And finally, log-based change data capture. We have transactional databases store all changes in a transaction log in order to recover the committed state of the database. So this webinar will focus on the diff strategy and using FME's change detector. There will be a part 2 to this webinar, which will be held in a few weeks discussing points 2 to 4, so be sure to check that out. It can be quite daunting and difficult to know where to start when it comes to changing data. So where do we start? I'm going to give a quick flash demo with the purpose of giving an introduction into a really cool and powerful transformer called the change detector. The purpose of this flash demo is to give a quick introduction into changing data in action and how FME can be used to make it far easier to understand. I'm going to introduce a very powerful and useful transformer called the change detector. The change detector detects changes between two sets of input features. In this flash demo, I'll show you how you can compare two Excel files containing business licenses from Vancouver. One file will contain dates from March 1st until March 15th, while the second file contains dates from March 1st until March 27th. The data was obtained from the City of Vancouver data portal. As we dive into FME, we will drag our two Excel files onto the canvas. In the visual preview, you can see all the information that the files contain. It contains a good amount of information regarding the business licenses, as well as the name, the status of the license, expiry dates, etc. Although moving between the two Excel sheets, as you can see on the visual preview, it's quite difficult to see if there are any changes or what has been changed. Searching through this manually is extremely tedious and time-consuming, as well as opening the possibility of human error by missing changes. With the feature counts, we can see there is a clear difference between the two Excel files, but I want a quicker way to be able to tell what has changed and where. I'll add in the change detector transformer. The change detector detects changes between two sets of input features, as mentioned before. We'll attach our Excel files to the transformer. The original will be from March 1st to the 15th, while the revised will contain the records from March 1st to March 27th. Opening up the transformer, we're greeted with the parameters. Let's compare by key attributes. We'll select license number. We'll also move down to the check attributes section. Here, we're going to select all attributes. Click OK and we'll run the workspace. Notice the results that have been produced by the change detector. As you can see, there have been over 586 new businesses added and 980 have remained unchanged. 15 businesses have been deleted while 4 have been updated. Clicking on the feature cache for inserted, you will be able to see which businesses have been added. Looking at the updated businesses, we can see that 4 have been updated in the past few weeks. This could be anything from status to business type to the name of the business. This was just a quick introduction into change detection to help give you a quick understanding of the transformer. The demos that will follow will go into more detail and show you more complex scenarios. As mentioned in the demo, the data was obtained from the City of Vancouver data portal. So thank you to them. It's a great website if you want to download some data and try out some of the scenarios we have in store. I'd highly recommend it. What is changing data? When we are speaking about changing data, we are looking at adding, modifying, or removing attribute values from a data set. You can see on the slide that we have a before and after with the change highlighted. So as you can see, the business trade name was the change. Emma will dive deeper into this topic, who will take it away with identifying and applying attribute changes.
Thanks, Donald. That was really good. To build on what Donald just presented, we'll start with identifying attribute changes. So the goal for the upcoming demo is to identify and apply changes from the latest City of Vancouver business license data to a local SQL Server database. So we want to ensure that the database stays current without the need to manually track updates, additions, or deletions. And the key here is to efficiently use the change detector to compare and detect changes between the original and the revised data. And with that, the SQL Server database will now stay up to date with the city's license data without any manual review or full table overwrites. So overall, this approach is very efficient and makes the downstream applications using the database way more reliable and current. So now let's go into the demo. So the workspace that you're seeing right now focuses on updating business licenses using data from the City of Vancouver Open Data Portal, very similar to the one that Donald just showed in the Flash demo. And as you can see here, we have two input data sets. The first is the revised data set in CSV format downloaded from the Open Data Portal. And then the second we have is the original data set pulled from an SQL Server database. So our goal here is to synchronize the original dataset with the most up-to-date version available. So before comparing the two datasets, it's very important to inspect your schema. So this change detector uses attribute names and values to compare features, and it's case sensitive as well. So we want to ensure that attribute names align across both datasets. So putting them side by side, we notice that most attribute match. However, we have the revised data set contains an extra attribute for the year, which isn't present in the original. So this is something we can remove later on. Just close this up, move it back here. So moving on to feature attribute values. So we want to look at the original attribute table right here. So everything seemed to look good, very similar to what Donald showed as well. Moving on to the revised one, we can see that the issue date have a different format. So we'll need to reformat it to match the original data set, which uses a year, month, and date format. And to clean up and standardize the data, we will use the attribute manager. Let's take a look here. So we will be removing unnecessary attributes like folder year and geom down here. And we'll also be reformat the issue date using the date time format function as well, as you can see. Okay, so now let's move on to the start of this workspace, the change detector. Let's take a look what's happening here. So you can see we are using the license RSN as the unique key for comparison. We've also selected key attributes to compare, such as business name, issue date, expiry date, so on and so forth. And you'll also notice that we've set the change list name to _changes. This adds a new attribute to each changed record, listing exactly which fields have changed. Super helpful for audit trails or downstream reporting. And as you can see here, the change detector classifies the data into updated, inserted, deleted, and unchanged ports. So let's take a look at the updated port. So since we've enabled the _changes, we can open the feature information window and inspect what's changed. So let's take a look here. So we can see that the original values from canceled get changed to issued for the first record. And the second record from inactive to issued, and so on and so forth for the 4 updated records here. You'll also notice that an attribute that change detector adds to each feature it processes FME DB operation. And this attribute is critical when writing to databases since you can use it to instruct the writer exactly how to handle each record. And FME DB operation is used to tag each feature as an update. For this one, for example, is insert for new records and delete for removed records, and we just have none for unchanged feature. And just quickly go back to updated here. So we have update for updated port. So by using FMEDB operation, you're not just detecting changes, you're also setting up FME to dynamically apply the appropriate changes in your destination system. So finally, all change records are written back to our business licenses table in the SQL server, basically writing it back to the original. So in here, we are using FMEDB operation as feature handling to ensure each feature is handled correctly, whether it's inserting, updating, or deleting from the database. We're also using the use existing mode with the license RSNs as the match column. So that's the end for this demo. Okay, thanks everyone for that. Let's quickly recap what we just saw. So we have our original and revised data sets, and we use the change detector to identify the differences. The change detector then categorizes these differences as updated, inserted, deleted, and unchanged features, and then they spit them out to separate output ports. And now let's just quickly go over them. As you can see in yellow here, the Mayor Floral had a small name change, so the word Company Inc. was added. Birdhouse Events Inc. had its status changed from inactive to cancelled, so these are categorized as updated. So in green, Novin Boom Construction Ltd. is a new record. It didn't exist in the original data, so it's flagged as inserted. In red there, Academy Duello Ltd. exists in the original, but not in the revised dataset, so it's treated as deleted. And finally, entries like the World Management Ltd. and Chance World Management Ltd. appear identical between the two versions here, so these are sent to the unchanged port and are not written back to the database. So yeah, here just a quick recap of all the changes in the revised database table. Just some quick tips and tricks before we moving on to the next demo. So often I like to ensure that the schemas of the revised and original datasets are matching prior to the change detector. It often makes life easier, especially when it comes to troubleshooting. So there are like these 4 transformers, for example, that you can use like attribute remover, keeper, renamer, manager to manage the fields. And for format mismatches such as case sensitivity or length limits, the bulk attribute renamer can standardize casing for that. And if comparing dates, you can ensure formats match using the datetime converter. And by generating a change list, you can determine what changed and use it in a report as well. And lastly, as I mentioned during the demo, the FMEDB operation attribute is the driver of change detection in FME. This attribute is used to set the writer's feature handling parameter to insert, update, or delete. And if FMEDB operation is blank, the feature handling defaults to insert. So now we have talked all about attributes. Let's go over how to identify and apply geometric changes. So the goal of the next demo is to detect and apply updates from newly submitted subdivision parcels to the authoritative ArcGIS Online or AGO parcel layers, keeping the system of record accurate, current, and in sync with the latest CAP submission. The key here is to detect changes with tolerance, align schema names, and writes only updated features to AGO. And lastly, the result is to have the AGO parcel data accurately updated with new subdivisions and edits. The process here is spatially accurate and reducing overhead for the team and ensuring the data source stays in sync with submitted plans. So now let's head over to the demo. So the workspace you can see here is designed to compare, identify, and publish changes to parcel and road data in ArcGIS Online. So we'll start with the original files coming directly from ArcGIS Online. Just quickly show you here. So these represent our system of record. This is pulled directly from AGO. And then we have the newly submitted CAD files, which may contain updated parcel boundaries or new subdivisions. And just quickly show you in Data Inspector here, and we want to update the original data with these new CAD files. To prepare the data for comparison, so we will be using the attribute exposer and reprojector to standardize the data and ensure that the coordinate systems match. And this will align the incoming CAD geometries with the spatial reference used by Eagle. And just like we did with the attribute comparison earlier, we'll connect the new CAD files to the revised port and the original Eagle files to the original port of the ChangeDetector. So now let's focus on the ChangeDetector. Let's open this up, see what's happening. So you notice that there's no update key attribute defined in this scenario. So as a result, only insert and delete outputs will be generated. And since we're dealing strictly with geometry and not attributes, we'll leave the check attributes box unchecked and we'll enable the check geometry here. And since there's no elevation data that we can see, match geometry is set to 2D. We've also enabled linear geometry matching, which tells FME to ignore the order of points in lines and area. This is useful because the revised and original data sets might represent the same geometry, but with different point orders. And if the order did matter, we could set this to no, but in this case, yes is appropriate. The check coordinate system is turned up here because we've already standardized the coordinate system using the reprojector earlier. And want to highlight the vector tolerance here, set it to 2. So FME can handle variations in precision or decimal places between geometries. The vector tolerance defines how much spatial difference is acceptable before a change is flagged. So in this case, we've set the tolerance to 2 meters. So that means if the difference between two geometries is greater than 2 meters, FME will treat them as different. And if the difference is less than or equal to 2 meters, they will be considered a match. This gives you control over how much leeway FME should allow before identifying something as true change. And since we're not detecting updates here, we don't create a change in list in this case. So once that's done, the updated features are passed through a string replacer to clean up layers names. And finally, a feature type filter sends the records to the appropriate output layers in Eagle, whether it's parcels or specific road types like local or lane. And that concludes my demo. So just to very quickly recap what we just did, we started by reading parcel data from Eagle, brought in new CAD files, then we used a ChangeDetector with a vector tolerance to find geometry changes. And finally, we wrote only the new or changed features back to Eagle, keeping everything up to date. Some tips and tricks when it comes to setting a vector tolerance. So just to reiterate what I talked about during the demo. So if I had a vector tolerance set at 0 or I'm not using it at all, any type of changes will be found down to the 8th decimal place. But if I set a vector tolerance of 3 and the change highlighted in this image would not be found even though there's 2 meter difference. And often units used by the vector tolerance are always the units of the feature coordinate systems. And there's a great blog on precision tolerance that I highly recommend everyone to take a look if you're not too familiar with geometry precision in GIS. And so now I will pass it over to Donald to talk about data synchronization.
Thanks, Emma. There are 2 great examples of the ChangeDetector in action, so really good job on that. At Safe Software, we realized that data synchronization is a huge part of managing data. So I thought it would be important to highlight this in our next scenario. So in this scenario, we're going to look at daily road closure updates from the City of Toronto using their data portal. It's very similar to the City of Vancouver, so I'd also recommend to use that as well. So we wish to have a confirmation email sent every morning to confirm that the changes have been updated. So how do we do this? Well, I'll show you now. For our final change detection scenario, we're going to look at the City of Toronto and specifically look at road closures. We have a road closures dataset that we're maintaining locally and require it to be updated incrementally from the source on the City of Toronto Open Data Portal. In this workspace, we've leveraged FME's ability to work with APIs. Since the City of Toronto allows you to access their datasets using an API, we will use the HTTP caller transformer to connect directly to the source dataset from the City of Toronto. We then break out the JSON response on what is being returned, using the JSON fragmenter. Here's a quick look at the JSON response. In the JSON fragmenter, we're also going to expose attributes that are required. Moving to the key part of the workflow, the change detector, we will open it up and review the parameters. As you can see, we have an update key, which is closure ID, and we also have our selected attributes. We're also generating a list as we want to see what has actually changed. The change detector also has an optional parameter that returns a list that describes what specifically has changed between the datasets. To enable this, create a list attribute in the detailed changed list name parameter. Here, we'll create a list called update. For original attributes to preserve, we select ID. This is to preserve the original geopackage ID of the updated feature. As you can see from the results, there have been changes in the past few days to road closures. We see 35 have been deleted, which suggests that the roads aren't closed anymore, while 47 have been inserted, which suggests 47 new road closures. Now that we have the results from the change detector, we can now write to our road closure geopackage table with the latest updates from the City of Toronto. Change detection is an extremely useful tool when you receive data on a frequent schedule. With FME, we realize that data synchronization is important to our users. Take this demo, for example. If we wanted to update the road closure table on a daily basis, rather than running this workspace here manually, we can publish this workspace to FME Flow, where you can automate it to run on a schedule and even send out a confirmation email. The first step is to publish this workspace and upload it to FME Flow. To save time, I have already completed this. With Flow, we're able to set a schedule, whether this be every hour, day, or month. It's totally flexible for your case and depending on your rate of change. For this example, we have the schedule set to send an email every morning at 9 a.m., as shown here. Schedules aren't the only option. You can add webhooks to trigger this workspace from other applications, or it can be totally reactive of messages or emails you receive. After setting the trigger, you can add an action, this orange object on the canvas. In this case, we are choosing to run the workspace we created to update our road closures table. Finally, we can then have a confirmation email sent depending on if the list has been updated or not. Again, there are several options to pick from depending on your scenario. So for example, for this scenario, if the road closures are updated that morning, you can receive an email confirming this, as shown here. As I said, data synchronization is extremely important, and with FME, we try to be as flexible as possible. This concludes our demos for this webinar, but I hope you are able to understand and appreciate the power that change detection can bring to your data. So after seeing multiple demos there, I decided to compile some general tips and tricks that I found very useful when using the change detector transformer. So the update key is required for you to get features flagged as updates. If no update key is selected, then features will only be flagged as an insert or delete. The attribute comparison, the change detector can compare all attributes, but performance improves if you limit it to only those expected to change. By default, missing, empty, or null attributes aren't considered different, but this behavior can be changed with a setting. Geometry comparison, for complex geometries, full geometry matching may be needed as it compares sideness, traits, properties, and values. By default, lenient geometry matching is enabled, which ignores the order of points in lines and areas. If points order matters, then disable the setting. There is also vector tolerance, not on the slide, but it's still important. It's very useful if dealing with different data sources that may handle different levels of precision in the geometry. Using this will allow the change detector to reduce or increase the level of tolerance used when comparing two features. Hopefully some of these tips and tricks will help you when working with the change detector. Finally, I'm going to pass this over to Dave, who's going to show you a demo in relation to reporting changes.
Thanks, Donald. I will now describe the reporting changes workflow. I will be demonstrating how to create a report of changes between two versions of Victoria Airport floor plans, which the Victoria International Airport allowed us to use for this demonstration. The key is to use ChangeDetector, HTML report generators, and HTML layout order transformers, which results in the ability to create an HTML report with specific layout order of two tables and a map containing the change data. In this demonstration's workspace, we have the revised and original versions of the Victoria Airport floor plan stored as a file geodatabase format. These two versions will first be geo-referenced before they are ingested by the ChangeDetector transformer. Let's open the ChangeDetector and see the parameter configuration. We are using object ID and FME feature type for the update detection key attributes because we do not have a unique or primary key. We can also see that check attributes and check geometry are enabled, as well as changed output. For the check attributes, the attribute matching strategy is set to match selected attributes. For the purpose of this demonstration, the selected attributes are name and notes. For check geometry, the match geometry is set to full with lenient geometry matching set to yes. For the changed output parameter, underscore updates underscore is specified for the detailed change list name. We have 3 bookmarks attached to the ChangeDetector transformer. While I will not go through all the parameters and the contained transformer in the bookmarks, I will provide an overview. The very top bookmark and its transformers are configured to trigger the Easy Translator workspace on FME Flow, which will convert the feature classes from the file geodatabase to an IMDF file format. The middle bookmark and its transformers are configured to create 2 tables for the HTML report. One table for the updated features and the other for the deleted features. There is an attribute creator in this bookmark configured to indicate what attributes were changed, which we can later see in the HTML report. The bottom bookmark and its transformers are configured to create a map. There are 2 other attribute creators in this bookmark that are configured to indicate which features are original and which features are changed for the pop-up information. The middle and the bottom bookmark are connected to the set HTML report order bookmark that contains 3 attribute creators. These attribute creators explicitly sets the number for the order of elements for the HTML report, which are sorted numerically in an ascending order by the sorter transformer, which the HTML layout transformer uses, then gets passed to the HTML writer. Let's look at the HTML report that is generated. Here we can see the table of updated features and the other table containing the deleted features, as well as the map of changed features. In the updated feature table, we can see the results of the attribute creator, which indicates that the geometry has been changed for these features. The deleted feature table also shows the object ID of the deleted feature and its corresponding source feature types. On the map, we can see the red features representing the original features, while the blue features representing the changed features. When clicking on the features on the map, we can see the pop-up configurations set by the attribute creator for the original and changed features, which you can interact with by clicking on these features. As you can see, the red features that I click on shows a pop-up information indicating that these are original features, while these blue features, such as this polygon, or these points indicate that these are of the updated features. The next step is to automate this workflow using FME Flow. In this demonstration's automation, we have a resource or network directory trigger that monitors any created or updated file geodatabase dataset. This monitors whether the latest version of the floor plan edits were pushed by the user or the technician. If a new version of a file geodatabase of this dataset or the dataset is updated, this triggers the workspace that I described earlier. If there were updated and deleted features detected from this workspace, this triggers the IMDF trigger automation writer, which then triggers the Easy Translator workspace that converts the file geodatabase data to an IMDF, which can be imported by users or other relevant stakeholders to their Apple Maps. Both the HTML report generated from the workspace as well as the IMDF file are then sent to the emailer, which notifies the users and the relevant stakeholders that the updated floor plan has been processed, along with the HTML file of the report as well as the IMDF file. To summarize my demonstration, we first read in 2 file geodatabase datasets to compare the Victoria Airport floor plans. Then we performed change detection for attribution and geometry using a double key. Then we configured the change output to generate a list of what was updated along with any new features or missing features. Then created a report that will notify users or stakeholders which features were updated and deleted. Then created a map for the change detection report. And we also explored the next steps of automating this workspace on FME flow to generate an IMDF model for stakeholders to use. Tips and tricks with Demo 4 includes limiting the selected attributes to check for change, which improves the performance and duration of runtime, and the use of CRC calculator and its CRC value for improved change detection.
That was a really cool demo. I'm hoping with the scenarios we demonstrated today, you can see that detecting change in the FME can be easy. FME cuts out any manual effort and there's no coding required. Change detection in FME gives you the power to detect, report, and apply changes to your tabular and spatial datasets. Incorporating change detection in your data integration workflows can help increase productivity by helping you operate more efficiently, saving you time from doing tedious tasks. If you've enjoyed this webinar and would love to learn more about managing changing data, be sure to check out part 2 of this webinar on April 23rd. Our team dive into plenty more interesting topics. As you can see, Safe Software is an ever-growing company. We now work with over 25,000 organizations worldwide from 128 countries. We have an active community of over 37,000 users, and it's constantly growing. Safe Software now supports over 500 data types in FME. FME is the only all data, any AI platform that helps you take control of your data and makes it work for you. We offer flexible deployment options. FME Form is the authoring environment where you build your data integration workflows, which you primarily saw today, and the automation can be provided in FME Flow. I will now hand it back over to Elizabeth, who will wrap this up and walk through the resources with everybody. Thank you.
Awesome. Thank you, Donald. Yeah, so just to take us through some resources to help you get started. Following today's webinar, we do have a wonderful change detection knowledge article available at our support centers. So we'll just drop that link in the chat now as well. But yeah, this is a great overview article. We encourage you to take a look and reference it as you go along with trying this out yourself. In terms of other free resources here at SAFE, we have our FME Academy, where you can access free instructor-led training. Also, our webinar program, we have some upcoming webinars over the next month or so that are posted already, and many more coming on the horizon, so keep an eye out on that page. And then lots and lots of on-demand webinars as well that you can search through. Next steps. So our part 2 webinar, very excited for this. We've been planning away with Dan and Luke, who will be presenting this content. we'll be focusing on those other 3 methods that we mentioned at the beginning of the webinar. So looking forward to that. We hope that you can join us for that. It'll be more of an intermediate to advanced level, just to note. I will send out that link to register now. We hope to see you there just in a couple weeks' time on April 23rd. Contact us. We'd love to help you get started with any of your data challenges or needs, info@safe.com. If you are newer to FME, I'd encourage you to take a look at our FME Accelerator course. It's just 90 minutes and free of charge, and it's a great way to learn the fundamentals of FME. Claim your community badge. If you're a member of our community, here is the badge code. I'll also drop that in the chat so you have it handy, that you can claim and redeem as a thank you for joining us here today. And if you aren't a member of the community, take a look, explore around there. Lots of great forum opportunities over on the community and networking as well. Once again, our peak of data and AI this May 6th to 8th in Seattle, Washington. We hope to see you there. But we do have some time remaining for questions. Yeah, almost over 15 minutes, which is awesome. And we had a lot of great questions to chat about. So I'll prompt the team if they want to join me on the stage now. We can take a look through questions together. Maybe pick out 1 or 2 that we want to get started with here. Thanks everyone for dropping in questions as we went. Very lively question panel today, so lots to discuss.
I can get this started. There was a few questions around comparing schemas and whether we can leverage the ChangeDetector to compare schemas. That's kind of changes in attribute names, the data model, or data types. As mentioned, I think on the first couple of slides, we do have an older webinar and some articles around this concept of schema drift. And the approach there, in, I guess, summing it up shortly, is using the schema scanner on the data sets that you're comparing prior to the ChangeDetector and comparing the output schemas from the schema scanner using the ChangeDetector there. So that was a great question that was asked a couple times.
And Chris is just wondering if we have the link to the schema drift webinar, so I will dig that up and drop it in.
I think I have it here a little bit.
Oh, perfect. Thanks, Tom.
From 2020, I believe.
Yeah, and just a caveat on that, we might have replaced whatever transformer they mentioned there with the schema scanner. So we've done quite a bit of work since then on the schema scanner transformer. So definitely replace whatever they're using in that webinar with the schema scanner.
Yeah, I just posted it into the chat for everybody.
Perfect. All right, is there any other question that anyone wants to pick out next?
I'll keep going unless somebody else has anything. There was a couple questions about kind of questions around what if you don't have a primary key to compare on, or what are the strategies around there? There's a couple there. One great one that Dave shared in the chat was around using the CRC calculator transformer and then using the output from there to compare changes. And that basically creates a unique ID based on each individual record. The other strategy there is if you have a composite key, so like if multiple attributes can be identified or can be used to identify unique records in a data set, you can use the update detection key attribute parameter that Donald shared in his first couple of demos to specify multiple key attributes there rather than just one primary key. So a couple of strategies there. Not sure if anybody else on the panel here has suggestions there.
No, I think, yeah, I'd agree with what you just said. Kind of covered it.
I think what we just described kind of addresses Kai Nam's question with millions of records where there it's very like ChangeDetector is a very performance intensive transformer, and using CRC and selecting certain attributes that you want to use to create a unique ID can accelerate the change detection at the cost of having a richer information of like the change output, I guess, lists. So yeah, with data sets with millions of records using CRC calculator to you, and then using the CRC value for the selected attributes or even the update detection key is very efficient.
Just covering Peter's question around if you request an update list, does this have one entry for each attribute that has changed? I'm wondering if you're talking about that change list that was demonstrated. If so, yes. So basically, it will highlight each individual attribute and list what the original value was and the revised or updated value was for each attribute in that list. Hopefully that answers your question, Peter.
For precisions for geometry, I think a common example is ArcGIS like portal or online feature service and geodatabase, where the geometries are slightly rounded, causing a difference in the specific values for the precision. I would lower the vector tolerance to a lower value so that it's not flagged as changed. With geodatabase and ArcGIS portal or online feature services, I usually set as 0.0001 so that these changes in the precision doesn't trigger the updated.
Yeah, just to quickly add on to that, it's the ground units for the coordinate system that you're using as well. So just also keep that in mind. You can open the feature information window and just kind of check what it is in, and then you know what it is. So for the demo that I used, the ground unit was in meters. So that's why the 2 meter.
And Nampreet, you're muted just in case you are speaking.
I was speaking. Thanks, Elizabeth. Yeah, to address John's question here, it's a great question around potentially triggering a workflow dynamically upon a change, say in a database. There's different strategies here depending on what your source system is. So with a database or a application system that supports webhooks, you can leverage webhooks in FME to trigger a workspace. So from the source system, once a change is detected, you can create a procedure that runs an FME process using a webhook on the FME flow side. There are other strategies there for sure, and I think hoping in part 2 of this series, they'll cover some of those as well.
Awesome. Just scanning through the questions one last time here. It looks like we just have one left unanswered. Awesome,
I can
thanks.
take this. Yeah, feel free to jump in here with this one. Yeah, I think it really depends on the data set. So if you're not expecting duplicates in your incoming data sets, definitely check for duplicates from, say, I'm assuming the revised data set in this case, so that it doesn't kind of mess up the comparison. So you can build in those validations and checks to ensure that you're comparing apples with apples, basically going into the change detector, whether that's looking for unexpected duplicates or even attribute names, as I think Emma might have mentioned in her demo. So hopefully that helps.
Perfect. Is there any other questions we might want to elaborate on. It does look like some people are typing more questions in as we go here, so that's great. We still have a few minutes, so if you do have questions, top of mind, keep typing them in. We'll keep an eye out. Anyone on the team want to pick one out? Yeah, I know we've gotten to most, but.
Yeah, and I'll just mention Peter's question. I'm not strong on the geometry change area, but I don't know if anybody here has some ideas to share about Peter's question here. It says, if you're differencing two long line objects, for example, a coastline with multiple segments, is the only way to determine the change segments to use a chopper transformer and then use a change detector on an individual segment. This might be a good approach, especially sometimes if the revised or updated version is in another format, or you're expecting kind of changes between your destination and revised formats, that may be an approach. I don't know if anybody has any ideas on other approaches to this problem from Peter.
That is probably the way I'd go about it, the way Peter suggested. I guess one other way is to kind of look at the vertex transformers, but it's kind of be similar. It would be either the vertex counter or creator off the top of my head, but it seems like Peter is on the right track, and that would be actually the way I'd go about it.
Yeah, I don't know, Peter, maybe we can follow up with some further ideas with you after the webinar as well.
Awesome. We also got a question about if I want to master everything FME as a current novice, what is the best route to achieve this? I think just top of mind, and I'm sure the team has other ideas too, but the FME Accelerator course is definitely a great place to get started. It's 90 minutes, no download required, free of charge, instructor-led. I can send that link again. Does anyone else have ideas to add there?
We do. Like, sorry, go ahead, Bill.
No, go ahead, no, please.
I'll let you go.
Okay, no worries. Yeah, the accelerator is definitely a great place to start. It's very useful, but then also dive into the FME community. It's extremely useful. It's a large community. Everybody asks questions, helps each other. You learn an awful lot while you're there. And then the knowledge base as well is just a depth of just endless knowledge that you can pick up on, whether it be working with ArcGIS to databases to complex CAD drawings. Yeah, I'd recommend that.
Adding on to what Donald said, I think using knowledge base article really familiarize yourself with the general workflows associated with different formats. And I think to master it, I think you need to see some real world, I guess, scenarios and applications and practice creating, I guess, customized workflows on your. Anything to add, Nampri?
Yeah, and just to mirror what Linda Stewart has chatted in the chat there, where even after, say, 15 years or so many X number of years, it's hard to master all that FME can tackle. And here internally at SAFE, we always say there's no one that knows the entire product here. We all rely on each other for each other's expertise to succeed internally, and also the FME community is one example where our user base can use each other's resources to succeed there as well. I also dropped another link into the chat around all of our free resources at Safe Software. It's fme.safe.com/resources, which kind of provides a link to everything that Elizabeth and Donald and Dave have mentioned as well.
Awesome.
Yeah, I agree with everything that all three of you said. I just also want to mention the FME Academy as well. We currently have some training going on. So it's run by our very, very well knowledgeable educators. So currently we have the FME Form Basic running, and we will also have advanced and the flow authoring courses coming as well. I'll drop it in the chat so everyone can take a look.
Yeah, and I think that link Nampreet sent is super handy too, because it has everything linked within it on that resources page, which is perfect.
With familiarizing yourself with different choices and settings within each options, another great way to learn this is looking at some of the custom transformers made by community members. You can always embed transformers and then edit them to see what's contained in those custom transformers and really see how other people might have configured those settings or added choices to really see and kind of incorporate into your design of spaces or custom transformers.
And then also just to add on to Dave's point, we did mention the FME community, and if you're unsure or on how to kind of set up your workspace and you're unsure on certain transformers, I would recommend to post into the community, because you will most likely get feedback and really, really great answers, some really great users on that website.
Awesome. So we have a minute left here. Any other questions we want to address live? There's a new one from Peter there.
I can quickly address this. I heavily rely on the change detector just in terms of the workflows I use, and haven't used the matcher very frequently, but I believe, and I could be corrected here by anybody else on the panel, where the matcher doesn't go into records that are updated. It's more of looking at unchanged versus I guess it goes into updated, but change versus change record. So there's actually, I just found a good article here that compares the different strategies around change detection and kind of has a small blurb around this. I'll share it in the chat here. There we go.
The question was also just asked if links will be available after the webinar's ended from the chat. No, anything hyperlinked in the slides for sure. I think a lot of these links are in the slides, but if there was anyone in particular you wanted to bookmark, I recommend copying that before you exit the webinar for sure. All right, we are just past the top of the hour. Thank you so much, everyone, for joining us for the hour here today. We really appreciate your time, and just want to extend a huge thank you to our presenting panel today. All three of our presenters are newer or new to presenting webinars, so huge shout out to Donald, Dave, and Emma, as well as our support team on Q&A, Nampreet, Carl, and Mac here today. And thank you so much as our audience for your time. We really appreciate it, and we hope you got a lot out of today's webinar. If you do have a moment to fill out our webinar survey, we really appreciate any feedback. I just sent out that link again. Thanks everyone, and we hope to see you on April 23rd. Bye for now.